Okay, so I'm going to first start off by talking about what some of you noticed about number 3. If you look at anybody's work up here around the room for number 3, you should notice that it's the same exact y-intercept and the same exact slope, which means it's the same exact line. So I was actually just being facetious, Isabel, when I told you to graph it again, but darker, right? Don't graph it a second time if it's the same line. Once you actually, look it up, Google it. Once you actually graph one of the lines, and you find the second line is the same, you have actually stumbled across an example of a solution that has actually infinitely many solutions. So any point on those lines will make both true because they're the same line. All right, now, there's more to it than just that. Okay, you'll see in this table that you really have 3 options going on here. What you did in number 1 and number 2, where you got an ordered pair, that was an example of a consistent and independent system that has one solution. I'll repeat that. What you did in number 1 and number 2, that ordered pair that you found, means that the system is consistent and independent, and it has exactly one solution. Okay? For real. All right? The examples we did together were consistent and independent systems because they had one solution. Now, I told you the third one had infinitely many solutions. That's called consistent dependent, because it has infinitely many solutions. And the fourth one, if you guys notice, the fourth one had different y-intercepts, but the same slope. So when you graph them, you got parallel lines. That is an example of an inconsistent system because it has no solution. And yes, you will have to memorize how to say all of this and all of those vocab words before the test next week. All right? Excellent, Josie. I know. Positivity. Excellent. So let's do one together. Isa, question.
Whenever we see, like, say we did the y-intercept and we see it has the same exact problem or no solution, do we have to graph it?
No. So what I'm going to show you with this example number 1 is that you don't actually have to graph them to determine what type of system you have. It's called classifying. So if you notice that you have the same line. Now, if I'm asking you to graph, right? Like if you're doing 1 or 2 on the homework and I ask you to graph them, please just graph one of the 2 lines if they're the same. If they're parallel, please graph them and then write the solution. Okay? Let's do number 1. We'll do it algebraically, Issa, so you can see it without graphing. Is the first one in slope-intercept form? It is. Y equals 3/2 x plus 9. See how it's just written where the y is on the other side? But it actually is in slope-intercept form. What about the second one? The second one is not. So I have to add 6x to both sides. So I'm going to get 4y equals 6x plus 36. Okay? Now how do I get rid of that 4? Divide by 4. So you get y equals 3 over 2x. Nice, Daniel. Well done. Daniel sees 6 over 4 can be reduced to 3/2. Well done. And then what is going to be 36 over 4? 9. Ah! Look at this one. And look at that one. They're the same line. So to classify, here we go. This is going to be the challenging thing on the test next week. To classify, I see all of this, Jonathan, not just infinite, all of this, consistent, dependent, infinitely many solutions. I think I've made it very clear. I'm not even going to respond to absurd how that question was. He wanted to use an acronym. CDIMS. And I would just put minus all of the points. Okay then. Are there any questions on this process? So once we wrote them in slope-intercept form, I noticed they're the exact same line. So I wrote consistent, dependent, infinitely many solutions. Brianna. Shh, listen to Brianna's question. Yes, they're like that's why I put commas. So you're saying the system is consistent because there is a solution, and you're saying it's dependent because there's more than one solution. How many solutions does it have, you ask? It has infinitely many solutions. So it's all one thing. Like it's all has to be there. Josie.
So when we're not grabbing it, we have to worry.
So what I wrote in the word, that's called classifying. What I did right here, right, I'll circle it, that is called classifying the system. It didn't ask me for the solution, Josie. It said, what is the classification of it? So when you do your homework, 3, 4, and 5 are going to be working on classifying. And you'll have to do all of this on the test next week. Any questions? So there are 10 minutes left. There's